Welcome to Developing Graphics Frameworks with Python and OpenGL, Part 28, Materials, Points, Lines, and Surfaces. In the previous video, we set up the base class for material objects, which define the general appearance of a mesh. In this video, we're going to extend that base class to include some of the key features that every material needs to have: shader code, uniform objects, and render settings. So in this video, we're making a very basic material, and this material will be able to render objects as points, lines, or triangles. And we're going to kind of do this in two stages, like a basic material class where we'll define the shaders, and then that will get extended into three other classes: point, line, and surface basic materials, where the render settings are defined. So again, a two-step process. The idea is, at the end, you could take some geometric data, some vertex data, for example, 4 points, such as these, and you could render them with these different materials. So here on the left, there's 4 points with 4 different colors, a gray, a red, a green, and a blue. This is a rendering with a point basic material. In the middle is a rendering with a line basic material, and the right is a rendering with a surface basic material. And notice the nice gradient shading. That always happens whenever data is interpolated from vertices. And these extensions of the extension are going to contain the specific OpenGL render settings we need for each of these different primitive types. So to begin, in the basic material class, there's going to be 2 attributes we need in the vertex shader. We need the positions of each vertex. That's the main job of the vertex shader, to assign that final position. We'll also need vertex colors. Now, you may or may not choose to use the vertex color when you're rendering different objects, but we'll set up the shader so it'll pass that data through to the fragment shader. So the uniform variables we'll need in the vertex shader are the model, view, and projection matrices. You might recall we need those to calculate the final position of each vertex. Now, when we're coloring these objects, there's a few different ways we're able to color an object. We could either use the interpolated vertex colors, which we saw on the previous slide, or we could apply a single color to all the vertices to have a solid colored object. So what we'll do is, in the fragment shader, we'll have 2 more uniform variables, which will help us set up both of these possibilities. First, in the fragment shader, we'll have a vec3 called base color. And this will be some color that's applied to all the vertices. We'll have that default to white. And that way, if we take the white color and combine it with other colors, it won't change the other colors if we multiply components. And the base color will be set to whatever the uniform variable specifying a single color is. Optionally, we'll let developers decide whether or not they want to use vertex colors with a Boolean variable, and it'll answer the question, do we want to apply vertex colors? All right, with this general game plan, we're going to go on over and open up our Sublime text. And within the materials folder, we're going to create a new file called basic material. So I'm going to right-click materials folder, a new file, and immediately save it. And I'm going to call this basic material .py. It's like an intermediate step. So from material, .material, import material. Also, from the, we're going to need uniforms again. So from the core directory, core.uniform, import uniform. And be careful that doesn't auto-correct to a lowercase. Okay, time to define our class. Class basic material, and this extends the material class. And remember, one of the main goals of this is to create our basic vertex and fragment shader code. So let's go ahead and define the constructor underscore underscore init. And first, we'll start off by writing vertex shader code, multi-line string, so 3 double quotes. So we'll need a uniform mat4 for projection matrix, a uniform mat4 for the view matrix, and a uniform mat4 for the model matrix. Other variables we need for attributes, we have an incoming vec3 called vertex position, an incoming vec3 called vertex color. And again, we want to pass the vertex color through to the fragment shader. So we'll have an outgoing vec3 variable. We'll just call that regular old color. Now we're ready to write void main. All right, so GL position is going to be equal to, let's see, might be easier if I write this in 2 lines. Let's say I have a vec4 just called position equal to vec4 constructed from the vertex position and adding in the 1.0, that homogeneous 4th coordinate. And then to calculate GL position, that'll be the projection matrix times the view matrix times the model matrix times the position. Oh, that's a lot of code. Let's shrink that for just a moment. All right, there's a lot of calculation going on. Fortunately, GPUs are optimized for this kind of calculation. We also need to pass through vertex color into color. So set color equal to vertex color. Nice. All right, and that ends the vertex shader code. Next, we need to write the fragment shader code. So I'm going to need to scroll down a little bit here. Let's see. So fragment shader code equals triple quotes. Let's see, I'll start off with uniform vec3 base color. That'll be kind of our starting color. Uniform, we need a boolean now. Bool, use vertex colors in vec3 color. Right, that's the color that was passed in from the vertex shader. It's an incoming variable here. And then we need an outgoing vec4 variable called frag color. Okay, now we can write void main. Okay, so first, let's say a vec4, set up a temp color by taking whatever our base color is and adding an alpha component. Right now we're going to make everything perfectly opaque, so that alpha is going to be 1.0. And then if we're using vertex colors, then we're going to take the temp color and just multiply it. So temp color times equals vec4. And I need to take these colors and add an alpha component to it. And finally, the final fragment color, is going to be the result of temp color. And as we'll see pretty soon, temp color is going to default to white. So in case you want to use vertex colors and not the base color, right, this code is going to work perfectly fine. Okay, closing the triple quotes there. That's the code for our basic fragment shader. All right, Now at this point, we're ready to call the constructor of the superclass. We weren't ready quite yet because we needed to write that code first. So let's put this code here. Superclass, call the initialization and supply it with vertex shader code and fragment shader code. Okay. The other thing we can do at this point, we know what uniform variables these shaders are going to require. So I can add some new things to uniforms. For instance, there's one called base color, and that's going to be a uniform. It stores vec3 style data. Again, I want to set the default color to be white, because as you saw, multiplying here, right, if you just want to use vertex colors but not the base color, you'll be multiplying by 1, each vertex color by 1, which will not affect the value at all. Next, are we going to use vertex colors? Right, so we have a new uniform called use vertex colors. That's a uniform, it's a Boolean type, and it's going to default to 0. So we use 0 for false. And now that we have all the uniforms accounted for, we'll say self.locate uniforms. Right, and that'll figure out the references to not only these uniforms, but the uniforms declared in the base class. All right, so that's our basic material. But as we mentioned, there's still OpenGL render settings to take care of. So we're going to make 3 extensions of this class, because really each one's going to have different render settings, and we need to implement the function update render settings differently for each one. So basic material is a great class, and we're going to create some more classes. So I'm going to go ahead and right-click the materials folder and make a new file. This file, I'll save it immediately, call it point basic material. Now, what do we need if we're creating a material for a point? I'm flipping back to a slide for a second. The render settings we need, well, we always need a draw style. In this case, it's points. We also can store the size of the points. We'll store that with an integer stored under the dictionary key point size. And finally, we have the option of making points rounded or not in recent versions of OpenGL. So we'll make that a Boolean variable. Okay, so with that game plan, we need to implement these 3. So back here, let's see. Now from material, we're extending the basic material. So from material.basic material, we're going to import our new basic material. And then, since we need some of the OpenGL constants from OpenGL.gl, just import everything for convenience. Now let's go ahead and define this class. Class point basic material. This extends basic material. Let's define the initialization and properties. All right, so first we'll set up everything in the basic material. That loads up the shader code. That stores and locates the uniforms. And now let's set up the render settings. First, we want to render the vertices as points. So self.settings, we call this one draw style. It's going to be GL points. Next, we want the width and the height of the points. The diameter, I guess. And that's measured in pixels. Self.settings, we said we'd call this one point size. Let's give it a nice large default value so those points are visible. Maybe let's set it to be 8. And do we want to draw points as rounded? Self.settings, let's say rounded points. Let's default that to true. It's pretty nice. And then once we have all those properties, right? So let's say self.setProperties. Now, this might seem a little bit convoluted, right? Why am I setting properties with properties when this is empty up here? Well, it might be that when you're using this class, you might want to override some of these settings, or you might want to override some of the uniform values. In that case, when you initiate this class, and there should be a space in there, when you initiate this class, you could then pass in the properties here at this level, and then properties will get sent in, and again, once everything is added, only then can you set properties. Remember, if you try to set a property that doesn't exist, it's going to raise an exception. And so this is the stage in the process where properties would be set. Okay, now that we know what the OpenGL render settings are, at this point we're able to define or implement the update render settings function. Update render settings self. And this is where we call all the OpenGL functions that we've learned about in previous videos, right? Like GL point size. You might remember we used to do that in the beginning of our applications. And this class will handle that for us. We'll set it to self.settings, whatever is currently stored under point size. And then we want to determine whether or not we want nice rounded points. Right, and that'll depend on this Boolean value. So self.settings if rounded points, self.settings brackets, rounded points, if that's true, then GL enable GL point smooth, else I'll say GL disable GL point smooth. All right, and that's it. That's the final task we need for a fully functioning material. We have the shader code, we have the uniforms, we have the render settings. So now we can render points, but we also want to be able to render lines and surfaces. I'm going to go ahead and save this code and create another material. So right-clicking on the material folder, a new material, let's call this line basic material dot py. And the setup is going to be extremely similar. And so from material dot basic material, import material, from OpenGL dot GL, import star. Class, this one is called line basic material. It extends the basic material class. Whoop. And I'm noticing by my lack of autocomplete options, I imported the wrong thing. That should be basic material. Okay, just as before, we're going to define an initialization function, potentially with properties. By default, no properties. So super.init. Let's see. So one of the interesting things about line materials, there's lots of different ways to group vertices into lines. As a continuous line, as a loop, so continuous and connecting first to last, or as individual line segments, like disjoint pairing off of the vertices. So by default, let's say we'll render vertices as continuous. Right, so self.settings, this is a dictionary, so brackets draw style equals GL line strip. Now, since we're making a framework for potentially other people to use, and even ourselves. We don't necessarily want to have to remember all the different types of OpenGL constants. Which reminds me, I should go ahead and open up this slide. All right, for the line basic material, again, the draw styles, there's 3 different styles. The line strip, which is connected, or line loop, which connects first to last, and GL lines, which just pairs them off. So it'll be easier as developers to maybe remember these strings instead of the OpenGL constants. So we'll also create a line type render setting, which would be one of these strings, which can then set the draw style accordingly. And since we're using lines, we also might want to be able to set the width of each line. So let's go ahead and head back to Sublime Text. Okay, so we have a continuous line and the line type. And again, this can be connected or a loop or segments. So we'll say self.settings brackets line type. By default, it'll be connected. That corresponds to GL line strip. And of course, line thickness. It'll be self.settings line width. And let's make it a fairly big number so we can see them more easily. By default, let's set that to 4. As we explained before, now is the time to set any properties they got passed in through that properties dictionary. That takes care of initialization. Now we need to implement the update render settings function. So let's do that next. Define update render settings. First, the easiest one is GL line width. And whatever is stored in our settings dictionary under line width, we'll pass that as the argument to this OpenGL function. And now we'll just have an if-else block. And it depends on what self.settings is. So if self.settings is equal to the line type setting, it's equal to connected, then self.settings, the draw type, or draw style, let's set that, so single equals, set that to GL line strip. Else if, I can just copy this, copy and paste twice. Else if the line type is, I said loop, is a possibility. In that case, the draw style will be line loop. And finally, if we're using segments, that's just GL lines. All right, and I need an if, else if, else if. And finally, just in case, let's add an exception clause. Else, let's raise an exception. Unknown line style plus self.settings line type. I guess I should call that line type. All right, let me move that up so you can actually read it. Okay, and that should cover all the different possibilities. That takes into account all the different OpenGL settings that we need for lines. Go ahead and save that one. One more, same kind of style. Right, we're going to create a surface basic material, which is going to use triangles by default to render. So to speed this up a little bit, I could copy these first few lines of code. So our next class is going to be very similar to this. In the materials folder, let's right click and make a new file. I'll immediately save it as surface basic material.py. In this case, the only thing I really need to change is surface basic material. It starts out the same way. So what do we need to do? Render vertices as triangles. Right, there's lots of triangle settings too. There's triangle strip, there's triangle fan. For simplicity, we're just going to use GL triangles. So let's say draw style equals GL triangles. Next question is, well, what other properties do we need? So let me go ahead and open this up again. All right, besides the draw style for a surface basic material, there's a few things we can do with surfaces. One thing is, are they double-sided? Now, often OpenGL, to improve performance and speed, will only render the front side of a triangle. Right? By default, I think that's the vertices of each triangle are specified in counterclockwise order. From that point of view, then that's the front side of a triangle. So you can choose whether or not to render both sides. Really, we can typically set this to true in a lot of our applications because they're not going to be very performance intensive at first. But if it's lagging and you've got a lot of triangles, you might set that to false. Wireframe, it's possible to render each triangle as just its outline. And so that can be true or false. And if you're using a wireframe rendering mode for your surface, you can also specify the width of the lines once again. So these will be the different settings that we have. All right. So let's go ahead and implement these settings in OpenGL. The next question is, do we want to render both sides? So self.settings, double side. We'll default that to true. The next question, do we want to render as wireframe? Just the outlines of the triangles. Self.settings, brackets, quotes, wireframe is equal to false. And let's also do line thickness. As always, this measurements in pixels. Self.settings, line width is equal to 4. And now's the time to say self.set properties, if any have been passed. Okay. Next, let's go ahead and implement update render settings. So def update render settings. All right, so first we need to figure out, there's lots of possibilities. Let's see, let's do this one first. If self.settings brackets quotes double side, right, if that's set to true, then we're going to disable the removal of backsides. The removal of hidden sides is often called culling. Again, it's enabled by default for performance purposes, but we're going to disable the culling of faces when double side is set to true. Else, we'll enable it. Next, let's handle the wireframe. Again, these are Booleans, so these are all if statements. So if settings, wireframe, then let's say this function is called GL polygon mode. How do you render your polygons? Well, I would like to render both the front and the back with lines, all specified using OpenGL constants. If wireframe is false, then we want to render both the front and back as filled in polygons specified by GL_fill. Finally, we can set the line width. In case you are in fact using wireframe mode, with self.settings, brackets, line width. Whew. And that is the surface basic material class. All right, we're getting really close to rendering now. Go ahead and save that file. We have a couple of geometry objects we can render, and we have some material objects ready for use. So once we have geometry and material, we put those together to make a mesh. The last thing we need to do is create the renderer class, but we'll do that in the next video. Once we've got that renderer class, we're going to be ready to put together our first application with this new framework. So it's very exciting, so stay tuned for the next video.